Here we have another derivatives example problem, and we want to differentiate the following using any of these four techniques. So here we have h of y is equal to the square root of 2y plus 3y plus 4y squared, all of that cubed. So this looks a little bit complicated, so we can go ahead and simplify it by putting our 1/2 power rather than seeing a square root. And after doing that, we can kind of see that we have a chain rule. So we have an inside function as well as an outside function. And so we know that we'll have to use the chain rule to differentiate this example problem. So we can go ahead and apply the chain rule where we'll have the 1/2 will come out in front. So we're differentiating the outside function. And we're going to leave the inside function alone. So that's the second step in our chain rule. And then we're going to take the derivative of the inside function. And so when we look at this inside function g of y, so this 2y plus 3y plus 4y squared, all of that cubed, we know that we can go ahead and use the power rule to differentiate this. But when we look at this portion of our function, we know that we're going to have to use the chain rule again. And the reason for that is because we have this cubed power and we have a function that's contained within it. So we can go ahead and differentiate this where we have g prime of y is going to be equal to 2. So this was from our first portion using the power rule. And then that's going to be added by 3 multiplied by 3y plus 4y squared, all of that raised to the second power, multiplied by 3 plus 8y. And this was obtained by using the chain rule. You can see here, this is the outside function. We left the inside function alone, and then we multiplied it by the derivative of the inside function. And so after that, we have our g prime of y term, and we can go ahead and add this term, or replace this g prime y term in our original differentiation, and we'll then have our solution. So this will be our solution after everything is put together.